All right, so for this lesson, we're going to continue talking about rate of change, and we're going to continue talking about rate of change with graphs and some comparing. So just as a reminder, nothing has changed as far as our formula. It's still the change in y over change in x. So remember, the change means we're going to subtract our y values, and then we're going to divide it by the subtraction of the x value. So that change, that delta symbol means change is subtraction. All right, so it says the graph below shows the total number of fish that a fisherman caught over a 5-week time period. It wants to know what is the average rate of change, and they want to know between t equals 2 and t equals 5. So the first thing I'm going to look at is my x and my y. So my x, my independent, is in weeks, and my y is the number of fish caught, which is my dependent. So the number of fish caught depends on the week. So this says t. So one thing I want you to think about, and I want you to remember, that t most of the time in math means time. And so my time in this particular problem is the week. So what we're going to do is we're going to create our own table of x and y values. And those x and y values are going to represent the weeks, and they're going to represent the fish caught. All right, so we're going to go and we're going to look at our graph, and we're going to find the x values for 2 and 5. So we're going to find the time and the fish caught. So at 2, we're going to go to the graph. We're going to go up until we hit the graph, and we're going to see how many fish corresponds with that. So at week 2, we have 50 fish. And then we're going to do the same thing for week 5. We're going to go up into the graph, see where it corresponds, and that corresponds to 90. So now that we've kind of made our table here, we know this is my first x, my second x, my first y, my second y. So we're going to complete our rate of change by using our formula y2 minus y1 over x2 minus x1. So my y's are going to be 90 minus 50. And then we're going to have our x's, which is 5 minus 2. So if we go to Desmos, we're going to hit that fraction button. We're going to do 90 minus 50, 5 minus 2, and that gives me about 13.3 fish. So again, if you notice in our problems, they all say about, meaning that it was within that typical number. So approximately. So about 13 fish per week. All right, so second one, this graph actually represents a quadratic. So for the second problem, this graph represents an exponential function, which we'll get into later, but for now we're just going to focus on the fact that we're trying to find the rate of change. So it says the graph below shows the number of bacteria present in experiment. So they want us to find the rate of change, but they want us to find between hour 2 and 4. So again, at the bottom, our number of hours, that's our x, and then the number of bacteria is our y. So we're going to create ourselves a table, and we're trying to find the values between 2 and 4. So we're going to go to our table, or go to our graph, and we're going to find 2, and we see that 2 corresponds to 2,000. And then we're going to go to 4, and at 4 we see that that corresponds to 8,000. So we're going to set up our rate of change. So we know that this is x1, x2, y1, y2. And again, the 1s and 2s are, it really doesn't matter which one you label where. It just, we label them as the first one, the second one. As long as you keep your order the same way for the x's and the y's, it doesn't matter. So we're going to do 2,000 minus 4 minus 2. So technically that's going to be 6,000, and you could put this in Desmos, but 6,000 divided by 2 is going to give me 3,000. So we are saying in this particular problem that the bacteria is changing at a rate of 3,000 bacteria per hour. All right, so the next one shows the graph of the distance Mila drove during her first 10 minutes of her drive to work. So just to kind of analyze this, we can see that my time is in minutes. Okay, so this is how long she was driving. The distance is the miles. Okay, so if we're looking at a comparison here, we're talking about minutes per, or miles per minute. All right, so we can see that as her distance changed, her time, as she continued to drive her distance, then obviously she was probably going a little bit faster because her distance was able to change quicker, and then again, kind of steadied off. But what they want for this particular problem is they want us to find the average rate of change, and they want us to find it between 4 minutes and 6 minutes. So again, my X is going to represent the minutes, my Y is going to represent the miles. So they want us to look between 4 and 6 for the rate of change. So I'm going to go to 4, and I can see at 4 that corresponds to 3 miles. And then I'm going to go to 6, and that corresponds to 5 miles. Okay. So if we're calculating our y2 minus y1 over x2 minus x1, that's going to be 5 minus 3, and then 6 minus 5. And if we put this in Desmos, again, 5 minus 3, we get 2. So it looks like she was able to go about 2 minutes per, I'm saying that backwards because it should be y and then the x. So she was able to go 2 miles per minute. All right, so the next one is kind of a comparison problem. It's not a graph. So it says, Sam and Jack ran the 2-mile race for the school team. The table below shows their first 4 races. So essentially this is one table, or this is 2 tables in one. So if I'm looking at my table here, I can see that these are my number of races. Okay, so this is the race for Sam for each race, and then this is the race for Jason in each one. So they want to know what is the difference. So difference is subtraction. So we're going to be subtracting, but what are we going to be subtracting? We're going to find the average rate of change of Sam and Jason, but we are focusing on race 1 and race 4. So we're going to focus on 1 and 4, and we're going to focus on that for Sam, and we're going to focus on that for Jason. So I would definitely organize this, and what I would do is, since we're going to be subtracting anyways, I would focus on Sam, and we're going to do our rate of change for Sam. So if we're focusing on Sam, we're going to do 1 and 4, and then 17.6 and 15.2. So this is going to be my x1, x2. This is going to be my y1, y2. So we're going to calculate Sam's rate of change. So we're going to say 15.2 minus 17.6, and we're going to divide that by 4 minus 1. All right, so we're going to go to Desmos, so 15.1 minus 17.6, and then 4 minus 1. And that's going to give me negative 0.8. So now we're also going to do Jason's time. Now, Jason, we're going to be looking at the race and his times over here. So this is Jason's y1 and y2. So for him, we're going to say 15.8 minus 18.5. And then we're going to divide that by 4 minus 1. So again, we're going to say we're going to set up our problem. And I get negative 0.9. Now, we've got our 2 individuals, but it does say that it wants us to subtract. So we're going to come down here and we're going to subtract these 2. Now, if we are subtracting, it is subtraction and there is a negative number. So this is going to be negative 0.8 minus negative 0.9. And we get that there is a difference of 0.1. So remember, the word difference is going to mean subtraction. Now, I do know that at some point they are going to ask you to do a problem like this where they're going to say which average rate of change is the least or the greatest. So the table below shows the home runs in Major League Baseball between 1990 and 1998. So if you notice, they're asking me to compare different intervals to figure out which one is the least. So if we're trying to figure out which one's the least, that means we're going to have to calculate all of them. So again, let me express that. If they're asking me to calculate the least, the only way that we can calculate the least is if we calculate every single one. So the best way to handle this is organization. So A is 1990. So we're going to focus on 1990 to 1992. Okay. So we're going to say, remember, this is my X and this is my Y. So we're going to do Y2. So 3,383 minus Y1. And we're going to divide our X2 minus my X1. So again, just to make sure we're clear, this is X1, X2, Y1, Y2. It's a horizontal table, so we don't go vertical anymore. We're going side to side to make sure we match up our pieces. And then we're going to substitute or go put this into Desmos. And then we're going to calculate that rate of change. 1992 minus 1990. So this first one has a rate of change of 33. So for this one, we're basically saying that the number of home runs for that year was increased by 33 home runs per year. So now we're going to go to B. So B was 1992 to 1994. So these right here. So if we're going to focus on those, this time this is X1, X2, Y1, Y2. So we're going to say 4,030, 3,383, and then we're going to say 1994 minus 1992. And again, we're going to go put this into Desmos, and we're going to calculate these pieces again. This one is going to be 323.5. So obviously this one had a lot more in that time frame. All right, so then we're going to go do the next one. So we're going to go do C, and we're going to do D. So again, I know this takes a little bit more effort because you're having to calculate all of them. However, it is simply just substituting in, or it is simply just taking your values and calculating the rate of change. There's nothing too crazy about it. All right, so I got 1994 to 1996. So this is going to be your X1, X2, Y1, and Y2. So we're going to look at 4,081 minus 4,030. We're going to divide that by 1996 minus 1994. Again, go put in Desmos. For that one, we get 23.5. All right, and then the last one. And then once we have that last one, we can look at which rate of change is the least in value. All right, so we're going to do 1996 to 1998. So we're going to do 4,962 minus 4,081. And we're going to divide that by 1998 minus 1996. That one we get 440.5. So this question said which one is the least. So if I'm looking at all of these, the one with the least is going to be C. If they'd asked which one was the greatest, then the answer would have been D. So you got to pay attention to that key phrase about least and greatest. For this one, it says the function f of s is graphed on the coordinate plane. They want to know what is the interval, and they want to know what is the interval of x's, so the domain, where the rate of change is 0. So if there is no change, that means that the line is going to be flat. If there's no change, a rate of change is 0, means it's going to be flat. So that's happening from here to here. So if we line that up, and we're looking at the domain, the intervals of x, we're saying that that's happening between the 4 and 10. And the reason we're saying that is because it started at 4, it's ending at 10, that's a starting and a stopping value, so it's a compound inequality. Now, for number 7, it says the graph below shows Blair's distance from home on a 6-hour trip. So during which intervals was her average speed the greatest? So given this time, it's not in a table, it's in a graph. Now, understand that just like in the table, I could say, remember t means time, so my time here is my x value. I could absolutely go through and make a table of values for each one of these. So from 0 to 1, I go to 0, I see that's 0, 0, and 1 is here. But the problem is that we can't predict that. Now, if we were actually able to see the exact number, then I could absolutely calculate my rate of change. So what we've got to think about is when it comes to change, and I'm looking at the graph, how do we know which one is changing the greatest? So when we're looking at a graph, the greatest change is going to be the steepest change. It's going to be the steepest part that you're comparing. So steepness means which one is more vertical. So obviously, if I do this line, that line is steeper than this line, or even this line, okay, because it's more vertical. If I'm looking at which one has the least amount of change, that's going to be the one that is the flattest. So the one that is more vertical is going to be the most change, and the one that's the flattest is going to be the least change. So what we're going to do is we're going to look at each section. So from 0 to 1. So 0 to 1 is this section here. Okay. So then my next one is going to be 3 to 4. So 3 to 4. So that one's completely flat. So that one's going to have the least amount of change. There's actually no change. So then we have 4 to 5. So 4 to 5 is here. I would say that that one definitely has more change than 0 to 1 because it's more steep. And then finally, I have from 5 to 6. So from 5 to 6, we're looking here. So the one with the steepest change is going to be from 4 to 5. That one's got the more vertical section. If they'd asked which one was had the least amount of change, visually it would be 3 to 4. All right, so for number 8, it says the average rate of change in this particular problem of the function between x equals 1 and x equals 3 is -2. So right now, they're telling me that we know the rate of change. The rate of change is -2. They want us to find the missing value of a. So if I look at -1, that goes to 3. If I look at 3, that's a. That's the missing number. So remember, my formula is y2 minus y1 over x2 minus x1. And we know that that equals -2 because we know that equals the rate of change. So I'm going to substitute in what I know, and I'm going to work backwards here. We know the rate of change. We want to find the missing number. So my y2 was the a value. That's what we're going to wind up solving for. My y1 is 3, so that's a minus 3. And then x2 is 3 minus x1 is -1. Now, I want to point out that this is a minus and a negative. When you're doing a problem like this, the formula is negative, and if these numbers are negative, that means there's a double negative there. And that equals -2. So I'm going to simplify this. I hope you know that minus and negative is going to turn into a plus sign, which is going to give me +4. So again, over here, if I calculate that, that's going to be 3 plus 1, and that equals 4. So this is going to turn into a minus 3 divided by 4 equals negative 2. So we're going to solve this, okay? Just like with any other equation that we've done previously, we're going to multiply that 2 over. So I have a minus 3 equals negative 8. And then finally, I'm going to add 3. So my missing a value is negative 5. So in this problem, so just to make sure we're clear, they said that the average rate of change is this number. So we know that the rate of change is already given. And they're telling us that they used negative 1 and 3. So we're going to make sure we use the correct numbers for the x values, and then we're going to work backwards by plugging in what we know in the formula. All right, so for this problem, they're telling us that they want us to calculate and determine the average rate of change, which one is the greatest. So again, they're asking us to calculate each interval. So 0 and 3, then 3 to 7, 7 to 9, and then 9 to 11. So again, organization is going to be key here because we're going to focus on our x's and y's, and we're going to focus on substituting for that particular interval. So we're looking at 0 and 3, so we're going to be looking at these first two data pieces. So we're going to say 1,900 minus 1,750, and we're going to divide that by 3 minus 0. So that's going to be 1,750, and then 3 minus 0 obviously is 3, so that's going to be 50. So each time I'm going to calculate this, and again, I've got to calculate every one of them, and I've got to calculate every one of them to figure out which one is going to be the greatest. So we're going to continue on, and the next set is B, which is going to be 3 to 7. All right, so 3 to 7 is right here. So we're going to say 1950 minus 1,900, and we're going to divide 7 minus 3. All right, so you're going to put this into Desmos, and once you put it into Desmos, I technically can see that it's going to be 50 divided by 4, which is going to be 12.5. But again, you substitute it just like you've been doing this whole time. So for C, we're going to do 7 to 9, and then when we get to D, it's going to be 9 to 11. So that's going to be 2,180 minus 1,950, and then we're going to do 9 minus 7. And again, you're going to put it in Desmos. And then once we do that, we're going to do 9 minus 7. And we get 115. So far, at this point, C has the greatest rate of change, but we're going to keep going. We're going to do 9 and 11. So we're going to do the Y values for the 9 and 11, and then we're going to substitute that into Desmos. So last one, and then we can finally compare which one is the greatest. And we get 30 for that one. So when I look at this one, the one that has the greatest amount of change is going to be 115. So 115 was C, and if they had asked for the least, then the least would have been B. All right, so this last problem, it says the table below shows the amount of times that Tyler studied for 4 math tests. The grade that he earned, which statement correctly describes his average rate of change? So if I'm looking at his average rate of change, I'm going to be looking at, again, the y2 minus y1 over x2 minus x1. However, they don't tell me which one to use. So if they don't tell you which one to use, just use the first and the last. Okay, so we're going to choose the first one and the last one. So this is going to be x1, x2. That's going to be the minutes that he studied. Then this is going to be Y1, and Y2, that's going to be his test grade. Okay? So when I go to calculate this, I'm going to say 92 and I'm going to say 92 minus 80. And then that's going to be 60 minus 0. So for this last one, we're going to put in 92 minus 80. And then 60 minus 0 is just going to be 60. So we get 0.2. Now, if you look at the answer choices, there is no 0.2 there. Okay, so how do we go about describing this? So this may be this is an instance where we would want to put this into a fraction. So if you remember the other day, we talked about fractions. Over here in this blue corner of this right here, there's a fraction button that appeared. So that fraction button, if I click it on and off, will turn my problem back and forth into a fraction. So I get 1/5 as my fraction. But the question is which goes with which? So let's remind ourselves that the top number is my change in my y over my change in my x. So we're going to look at the y's and x's in my table up here. So if we're looking at our y's and x's, so my y was the test grade, so that's going to represent this first number. And then my x's are my minutes, that's going to represent my second number. So this is going to represent the grade, and it looks like in the answer choices that they're doing the grade in points. And then the 5 is the x's, that's representing the minutes. So basically what we're going to be saying here is we're going to say it's 1 point. So 1 point every 5 minutes. So you got to be able to look back at your table and make sure you know what the context is for the x and what the context is for the y. So this says 1 point, and this says every 2 minutes. So that's not what we're looking for. That's out. This says 1 point every 5 minutes, which is exactly what we're looking for. So the answer here is B. All right, if you have any questions about this, just let me know.